Can I screen share? Okay. Okay, so today we'll be talking about bonding and naming, and we're going to learn a little bit more about atoms, molecules, and ions, mostly just ions. So this is a small chart for Lewis dot diagrams from last class. In case you wanted to like draw them, these are the answers for most of them, or like the main elements that are like metals and gases and stuff. Yeah. Anyways, ions are okay, well, atoms are always neutral because they have an even number of protons and electrons. So ions are basically atoms that have gained or lost electrons, therefore causing an uneven number of protons and electrons, creating a net charge. So basically like an atom with a net charge is called an ion. So like if it's a positive ion or a positive atom or like a negative atom, then it's called an ion. So like, for example, if there are 6 protons and 6 electrons, it would be like an atom because it's like neutral. Like if there's 6 protons and 5 electrons, the charge would be +1, therefore like it's a positive ion. But if there's 6 protons and 7 electrons, the charge would be -1, therefore it's a negative ion. So also like only electrons can be gained, lost, or shared, but never protons. Like protons are in the nucleus, so they stay there and they don't do anything. But electrons are always the ones like moving around because they participate in bonding. So to get a positive charge, an electron is lost, and to get a negative charge, an electron is added. Like protons just never participate in this. Okay. Um, Positively charged ions are called cations, and negatively charged ions are called anions. So a good way to remember this is cations are positive, like get it? Because like cat and like paw, so like yeah, cations positive. So then anions would be negative. Um, that is very important terminology to remember. Also know that monatomic means one atom, and polyatomic means many atoms, because mono means one, poly means many. So a single atom would be like H plus or like Ca2 plus, Br minus, N3 minus, because you can see that it's only hydrogen, only calcium, only bromine, only nitrogen, right? But polyatomic could be like NH4 plus, because it's nitrogen and hydrogen in one thing. OH minus is oxygen and hydrogen together. SO4 2 minus is like sulfur and oxygen together. So yeah, monatomic, polyatomic, cations, anions. Okay. Also, I'm going to introduce you guys to the octet rule. It's pretty basic, but atoms tend to gain, lose, or share electrons in order to get a full set of valence electrons, which means 8 valence electrons. They only gain, share, and lose electrons, never protons. Again, only electrons participate in this bonding. So to obtain like a full set of valence electrons, or like an octet, most atoms need 8 valence electrons for a full set. Uh, because 8 is like oct, so octet. Yeah. So there's 2 types of bonding. One is ionic bonding and one is covalent bonding. Here it says gaining or losing electrons turns an atom into ions, and then because there are 2 ions, they bond like that. Well, I'll explain it later. I have a full set of slides just to explain ionic and covalent bonding. So yeah, basically just remember that atoms will do whatever they can to get a full octet, which means they would want 8 valence electrons. So basically, ionic compounds and ionic bonding. Here are some properties of ionic compounds. they've got high melting points, they're brittle, they're usually salts, they can dissolve in water, and they can conduct electricity because they're ions, and then ions are charged, like as we just learned. So because they're charged, they can conduct electricity. Okay. Ionic bonds. So basically how it works are electrons are transferred from one atom to another. So it creates ions. For example, NaCl. If if Cl gives Na an electron, then Na would become Na plus and Cl would become Cl minus. And because one is positive and one is negative, they attract and they bond and create the compound NaCl. So cations are attracted to anions because positive and negative attract. Metals and nonmetals are normally what ionic bonds are made of. So like a metal is bonded to a nonmetal. Um, Metals form cations and nonmetals form anions. So metals are always the ones that gain the electron and become positive, and nonmetals always lose the electron and become negative. And because they're positive and negative, they bond because, yeah, positive and negatives attract. Here there's a small video about bonding. Um, it's I don't think it's that helpful, but it's pretty funny or like cute or whatever. It could help you understand some things, but yeah. So as I said before, this is basically an example of bonding where the Na gives Cl one electron. So here, oh wait, yeah, I did it wrong. But anyways, they give an electron to Cl. So when Na loses an electron, it becomes more positive, right? When Cl gains an electron, it becomes more negative. So when Na and Cl are attracted to each other, no, when Na and Cl become ions, like Na plus and Cl minus, they are attracted to each other because opposite charges attract. So the Na plus and the Cl minus bond to form an ionic compound, NaCl. Does that make sense? Where one electron is given off, and because Na loses an electron, it becomes Na plus. Cl gains an electron, it becomes Cl minus. And because Na plus and Cl minus are like a positive and negative ion, they are attracted to each other and they bond. And that is called ionic bonding. And they form the compound NaCl, which is also known as salt. So here's some practice with Lewis dot diagrams and bonding, like putting them together. So basically, if you want to do it, if you want to draw ionic bonding with Lewis dot structures, this is how you would do it. Where you draw the Lewis dot diagrams for each of the elements, which again is just how many electrons, how many valence electrons each element has. So Na only has 1, Cl has 7. So Na would give its electron to Cl, so then Cl would have 8 valence electrons. Okay, and then Cl becomes Cl minus, and Na would become Na plus. So you draw the arrow indicating the transfer of electrons. So once Na plus and Cl minus combine, they become NaCl because it's a plus and a minus. Okay. Here's some tips. So the total net charge of the compound should be 0. So as you can see here, the Na ion only has like a +1 charge. Cl ion has a minus charge. But together, NaCl has a neutral charge. There's no signs or anything. It just says NaCl, no pluses or minuses. And you also have to determine how many of each ion you need to to balance out the charges. So in this case, it's just +1 and -1, so it's easy, right? But in other cases, you might have to do some math with like ratios just to like figure out how to do it, which isn't that hard. But for example, the magnesium ion and the oxide ion, it's 2 plus and 2 minus. So the final solution is just MgO, right? So I'll give you guys some time to figure out the next two. The calcium ion and the bromide ion is 2 plus and 1 minus. So how many of each element, or how many of each ion would you need to balance it out? I'll give you a second to figure that out. Okay, so because it's Ca2 plus and Br1 minus, it becomes CaBr2. See, you need two Br minuses to become 2 minus. And because it's 2 plus and 2 minus, it all balances out and it becomes CaBr2 with no charge. Now you guys can also go ahead and do strontium and nitride. So Sr2 plus and N3 minus. How many of each would you need to balance it out? Okay, so if you work with ratios, here it's 2 plus and here is 3 minus. You need to find like the lowest like common denominator. I think that's what it's called. So the closest number between 2 plus and 3 minus is 6, right? So in order to obtain 6, 6 divided by 2 is 3. So you need 3 strontium ions, and 6 divided by 3 is 2. So you need 2 nitrate ions. So the final answer would be Sr3N2. So then you can see that the charge of Sr becomes 6 plus, and the charge of N becomes 6 minus, because 3 times 2 is 6, and 3 times 2 is 6, right? If that didn't make sense to you, then you could also use the crisscross method, where you'd basically just like take the superscript of one element and just make it the subscript of the other. For example, Mg2 plus and Cl1 minus. Instead of just making Cl1 minus into 2 minus, you could also just take the 2 here and move it across and make it Cl2. And then you could take the 1 here and make it Mg1. So then Mg with Cl would be Mg1 Cl2, but you'd never write 1s. So then the final answer would be Mg Cl2. So if you didn't understand the regular way to do it, which is just like finding the positive and negatives and like balancing it out, you could just use this method. Okay, so this is the interesting part where you can sound scientific. You can use this part to like just sound very smart to your friends. Okay, so this is where we name ionic compounds. So you always name the cation using its element name. So the cation is the metal, the positive one. And you can name the anion by dropping the end of the element's name and adding "-ide". So yeah, but if the anion is polyatomic, instead of using the full name, add 8. So for example, here you can see Mg, I don't know if you guys can see the gray thing, but okay. Damn it. Mg, here. Mg3 plus, no, wait, yeah, Mg3 and PO4 2, right? PO4 is a polyatomic ion because it's got more than one atom in it. So therefore you call this magnesium, because you always name the cation with its elemental name. And then you say phosphate because you add 8 at the end, right? But here, NaCl, Cl is just a single element anion. So you call this sodium because you call it by its first name. And then chloride, you always end with IDE if it's a regular ion. Okay, so that's basically how you name ionic compounds. Here's some practice with it. So FeO would be iron 2 oxide. KCl is potassium chloride. right? CaF2, you have to figure it out, calcium fluoride. But here, Na2CO is sodium carbonate because CO is a polyatomic ion, right? So because it's polyatomic, you would use H instead of "ide." Nathan, what's your question? Did I answer it? Okay. Well, don't be afraid to just say it again. Anyways, covalent bonds. Wait, why is the 2 on the bottom? Uh, for which one? For the CaF2? Okay. Uh, because you would have 2 fluoride ions. Because here it's Ca2 plus and F minus. So in order to balance it out, how many fluorides would you need if it's Ca2 plus and F1 minus? You would need 2 fluorides, right? So then it would be 2 plus and 2 minus. So then it's CaF2 because you need 2 fluorides. Um, on the bottom is how many of each element you need. On the top, you would write the charge. So you see here on the top, you would only write the charges, right? But then like in the final answer, you would write on the bottom because like that's how many of each element you need. You got it? Yeah. Okay. Okay, cool. Glad I answered that. Um, so now we're gonna move on to covalent bonding. This is like significantly easier. You don't need as much math required, I think. Anyways, covalent bonds are formed by a pair of electrons that, like between two atoms. Wait. Okay, wait. The 3 plus and 2 minus thing. On the bottom here. Okay, so here it's 2 plus and here it's 3 minus, right? So you want like a common number. So the common number would be 6, or yeah, it would be 6. So you would want 6 plus and 6 minus. But in order to obtain 6, you would have to multiply 2 plus by 3. So then you would have 3 here. And to obtain 6 minus, you would have to multiply 3 minus by 2. So you'd have 2 here. Does that make sense? Nathan? Here, I'll type in the chat where you want to get to 6 plus and 6 minus. So 2 plus, wait, 3 times 2 plus equals 6 plus. And then 2 times 3 minus equals 6 minus. It's in the chat, by the way. So because you would multiply it, because you multiply by 3 and 2, that's what you would write on the bottom, because that's how many of each element you need. Yeah, because I I wish I had a pen and paper to do this because it's a lot easier to explain there, but like you want to find 6, right? But in order to get 6, it's like multiplication and like ratios. So right now your ratio is like 2 plus to 3 minus, and you want to get to 6 plus to 6 minus. And in order to do that, you need to multiply by 3 on this side and multiply by 2 on this side. Does that help? Okay, cool. So back to covalent bonds. Covalent bonds are formed by a shared pair of electrons between 2 atoms. And covalent bonds only happen between nonmetals. Okay, so ionic bonds happen between a metal and a nonmetal. Covalent bonds are only between 2 nonmetals. So here are properties of covalent bonds, not compounds. Well, it's kind of the same thing, but not really. So they've got low melting points, they're soft and flexible, many won't dissolve in water, and they can conduct electricity even if they do dissolve because they don't have any charges. They just share the electrons. Nothing is being transferred. Okay, so yeah, naming covalent compounds or molecules, it's kind of the same as naming ionic compounds, but like the prefixes are added to like the ratio of atoms in the compound. So like uh in case you didn't know the prefixes for like the numbers, it's kind of like the shapes where you have like a heptagon, octagon, nonagon, all those things. You just like take the prefix of it. So 1 would be mono, 2 would be di, 3 would be tri, 4 is tetra, then penta, hexa, hepta, octa, nona, deca. I have this chart here. Of course, I'll put it back. I'll put it on Google Classroom for you guys if you need it. But you guys would probably get it. So for example, Si to Br6. There's 2 Si's, right? So it's disilicon. And then there's 6 Br, so it's hexabromide. And at the end, you always add "ide." So it's hexabromide instead of bromine. Does that make sense? Because there's 2, so it's di, and here there's 6, so it's hexa. You basically just add the prefixes and that's it. And you, monogram and a diagram. Nathan just messaged me and asked if there's a shape that starts with mono or di. So, kinda. Monogram and diagram, or like monatomic, diatomic. But mono means 1 and di means 2. That's all you really have to know. And you never include mono in a prefix for the first element listed. So for example, here it's CF4. So you never say monocarbon, you just say carbon, and then tetrafluoride because it's 4 fluoride, so tetrafluoride. Okay. Why is this being weird? Okay. So here's some practice with naming covalent compounds. NO would be nitrogen, not monnitrogen, just nitrogen, because it's the first element. And then monoxide. So you always end it with an "ide," and then you have the number mono because it's just 1. So N2O, dinitrate monoxide, because there's 2 nitrates and 1 oxygen. So S2Cl, disulfate monochloride. Cl2O7, dichloride pentoxide, because there's 2 chlorides and 7 oxygen. So di 2 pent 7. So P4S9, tetraphosphorus, because there's 4. 4 means tetra. Nona-sulfide. So nona means 9. So S9 would be nona-sulfide. It's pretty straightforward. You just have to add the prefix at the beginning and then add "-ide" at the end. All right. So now we're going to talk about some polyatomic ions. So as we learned previously, polyatomic means there's many atoms, right? So like an ion like O2 minus, that's just a regular ion because it's only like composed of oxygen. Polyatomic ions have more than one elements that create this like charge. So polyatomic ions, 10 is, I forgot what 10 is. 10 is deca. Yeah. So polyatomic ions are just given ions that are composed of 2 or more atoms, because poly means many, like I just said. There's actually a list of polyatomic ions, so you don't have to like remember them, or you don't have to like calculate the charge every single time. And the charges of the polyatomic ions are for like the whole thing, so like both elements, or like more than one element, not just individually. So once you get into like slightly more advanced chemistry, you're going to see these ions a lot. So Hg2 is composed of like 2 mercuries and it's 2 plus. Okay, but like ammonium NH4 plus, the whole thing is a plus, not just hydrogen. NO3 minus nitrate and C2H3O2 minus, it's acetate. The whole thing is just 1 minus, right? You guys can read. I don't have to say it out for you, but being familiar with all of these would be very helpful, and being able to combine them with other elements is also very helpful. So, yeah, this is the list. Memorizing them would definitely work towards your benefit, but like, you shouldn't just sit down and like look through this list and read it millions of times. You would memorize it by like just working with them a lot, like looking at them in problems and trying to like combine them with other elements, and you'll like become more familiar with it. Yeah, you definitely don't have to memorize it though. But here's the list. I think it'd be helpful for you to print it out or take a screenshot of it or something, and I'll put it on Google Classroom. So because today was a pretty big lesson, here's some like review or key points. So some good things to remember are cations and anions. Cations are positive, anions are negative. You have to know monatomic and polyatomic. Again, monatomic means 1, polyatomic means more than 1. Ionic bonding is between a metal and a nonmetal. Ionic naming, you only add "-ide" or "-ate". For covalent bonding, it's between 2 nonmetals, and covalent naming is you'd have the numeral prefixes and then add "-ide". So here's some homework. Of course, it's optional. I think it's very good practice, especially if I didn't do such a good job explaining. These worksheets should have some tutorials for you or something, because I think like the way that I'm doing this course, we're learning everything like a different order, so you might not be familiar with a lot of things. But here's the bonding worksheet, and then there's an answered key linked right here. The naming worksheet is right here. You can skip the first section because it has like Roman numerals, and we haven't talked about that yet. The answers should be on the next page. And then here's like a unit review with like reminders and notes and how to do things. It's got like Lewis dot diagrams, valence electron stuff, bonding, naming, all that good stuff. So again, if you have any questions, do not hesitate to contact me. Here's my contact information, blah, blah, blah. Thank you so much for enrolling. I'm so sorry about today being late. But I'm hoping you all learned a lot from today. Thank you so much for coming.